Hello dear students, in this video I will continue with the assertion reason based MCQs. In this video we will see some assertion reason based MCQs from the third unit, which is calculus. So these questions I have taken mostly from the Oswald's sample paper and Oswald's MCQs. So here we have the instructions for the following questions. Two statements are given, one labeled assertion A and the other labeled reason R. Select the correct answer to these questions from the codes 1, 2, 3 and 4 as given below. So we have to choose the first code when both A and R are true and R is the correct explanation of the assertion. Then we have to choose 2 when both A and R are true but R is not the correct explanation of the assertion. Then we have the next code 3 where A is true but R is false. Then for 4, A is false but R is true. So having these codes in mind, we will start with the assertion reason based questions. The first question, assertion, it is given that at x is equal to 1, the function x raised to 4 minus 62x square plus ax plus 9 attains its maximum value on the closed interval 0, 2. Then the value of a is 120. Reason, to find the value of a, we have to put f dash of 1 equal to 0. Okay, so here we can see that the assertion is given. It is given that the maximum value for this function, it is attained at x is equal to 1 on this closed interval 0, 2. We have to find whether the value of a is equal to 120 or not. So to find the value of a, we have to put f dash of 1 equal to 0. So this is true. Here we can see that the reason is true. Now let us check whether the assertion is true or not. So here we have f of x as x raised to 4 minus 62x square plus ax plus 9. So f dash of x, it is 4x cube minus 124x plus a. And now we know that the maximum value of this function will be attained either at the endpoints of this closed interval, that is at 0 and 2, or it is attained at the point where f dash of x is equal to 0. Here it is already given the maximum value is attained at x is equal to 1. So we have f dash of 1 equal to 0 implies f dash of 1 is in place of x, we have to put 1. 4 minus 124 plus a equal to 0, or minus 120 plus a equal to 0, a is 120. So the assertion is also true. So here we can see that both a and r are true and r is the correct explanation of the assertion. So the correct option is option A. Moving on to the next question, the total revenue in rupees received from the sale of x units of a product is given by r of x is equal to 3x square plus 26x plus 15. The marginal revenue when x equal to 15 is rupees 116. So this we have to check. The reason they have given is marginal revenue is the rate of change of total revenue with respect to the number of units sold. Therefore, marginal revenue at x is equal to 15 is the derivative of the revenue function at x is equal to 15. So here we can see that the reason is true. Marginal revenue, it is the rate of change of total revenue with respect to number of units, and if you want to find the marginal revenue at x is equal to 15, we have to find the derivative of the total revenue function and substitute x as 15. So the reason is true. Now let us check whether the assertion is true or not. So r of x is given as 3x square plus 26x plus 15. So marginal revenue will be dr by dx. It is 6x plus 26. Marginal revenue at x is equal to 15. It is the derivative of the revenue function at x is equal to 15. So it is 6 into 15 plus 26. which is 90 plus 26, 116. So here we can see that the marginal revenue when x is equal to 15 is rupees 116. So the assertion is also true. So here both A and R are true, and R is the correct explanation of the assertion. So the correct option is option A. The next question, the function given by f of x is equal to 3x plus 17 is strictly increasing on R. Reason, the logarithmic function is strictly increasing on 0, infinity. So here we can see that the reason is not a correct explanation of the assertion. Now let us check whether the assertion and reason are true. The assertion is f of x is 3x plus 17. And now we know that for a function to be increasing, we have f dash of x more than 0. So from this we have f dash of x, it is equal to 3. This is more than 0. So the meaning is that f is strictly increasing. And next we have under reason, the logarithmic function is strictly increasing on 0, infinity. So if we consider the logarithmic function as some other function g of x, say. So here we can see that x is greater than 0. Now g dash of x, it is equal to 1 by x. Now we can see that 1 by x, it is greater than 0 for x greater than 0. Hence we can see that the logarithmic function is strictly increasing on the open interval 0, infinity. So here assertion and reason are true, but R is not the correct explanation of the assertion. So the correct option is option B. The next question, assertion 2 is the least value of a such that the function f given by f of x is equal to x square plus ax plus 1 is strictly increasing on 1, 2. Reason, minus 2 is the least value of a such that f given by f of x is equal to x square plus ax plus 1 is strictly increasing on open interval 1, 2. So here we can see that the reason is not a correct explanation of the assertion. So either assertion should be true or reason should be true. Now let us check which is true and which is false. They have given f of x as x square plus ax plus 1. And it is strictly increasing on the open interval 1, 2. If it is strictly increasing, then we have f dash of x greater than 0. F dash of x is 2x plus a. This is greater than 0 on the open interval 1, 2. So from this we have f dash of 1 greater than 0 implies 2 plus a greater than 0 or a greater than minus 2. And f dash of 2 greater than 0 implies here we have to put x as 2. 4 plus a greater than 0. So from this we get a is greater than minus 4. So if we see on the number line, here we have minus 4, here we have negative 2. A greater than minus 4 consists of this part and a greater than minus 2 consists of this part. So the region which is common to these two, it is this part. So the least value of a such that the function given by x square plus ax plus 1 is strictly increasing on open interval 1, 2. It is minus 2. So this is the least value of a. So the reason is true and the assertion is false. So the correct option is a is false but R is true. The correct option is option D. Next question, the function f of x equal to log x does not have maxima or minima. Reason, the function f of x equal to log x has maxima. Here we can see that the reason is not a correct explanation of the assertion. Now let us check whether assertion is true or the reason is true. So here we have the function g of x equal to log x. Since log is defined only for positive values of x, we have x greater than 0. And now g dash of x equal to 1 by x. This is more than 0. Now we cannot find a point C such that g dash of C equal to 0. If we are able to find a point C such that g dash of C equal to 0, then we can see whether this function g of x equal to log x has a maxima or minima. But there is no point C such that g dash of C equal to 0. Hence the function g of x equal to log x, it does not have a maxima or minima. So the assertion is true and the reason is wrong. Hence the correct option is option C. Next question, given y equal to x by x square plus 1, then the value of second derivative at x is equal to 1 is minus half. The reason is y double prime equal to this function. So let us check whether y double prime equal to this function. Then in that case the reason will be true, and let us check whether the assertion is also true. So here we have y equal to x upon x square plus 1. Here we have to use the quotient rule to find the derivative of y. So the derivative of y given by y prime is the quotient rule, denominator the whole square, the numerator keep the denominator, differentiate the numerator, minus keep the numerator, differentiate the denominator. So it is x square plus 1 minus 2x square upon x square plus 1 the whole square. So this is 1 minus x square upon x square plus 1 the whole square. So this is y prime. Now let us find y double prime. Again we have to use quotient rule. So denominator the whole square, x square plus 1 the whole raised to 4. Here we have to keep the denominator and differentiate the numerator, minus keep the numerator, differentiate the denominator. It is 2 into x square plus 1 into 2x using chain rule. So the derivative of x square plus 1 the whole square is 2 into x square plus 1. Then we have to differentiate x square plus 1. When we differentiate x square plus 1, it is into 2x. So if we want to find the value of second derivative at x is equal to 1, we have to put x is equal to 1 in y double prime. At x is equal to 1, y double prime will be 1 plus 1 the whole square into minus 2. Here we have 1 minus x square. So if we put 1, this entire product will be 0 upon 1 plus 1 the whole raised to 4. So here there is 1 minus outside. 1 plus 1 the whole square is 2 square, into 2 it is 2 cube. 1 plus 1 the whole raised to 4 is 2 raised to 4. So this is minus half. So at x is equal to 1, the value of the second derivative is minus half. The assertion is true, the reason is also true, and R is a correct explanation of the assertion. So here both A and R are true, and R is the correct explanation of the assertion. So the correct option is option A. Moving on, the next question, the slope of normal to the curve y equal to 4x square minus 14x plus 5 at x is equal to 5 is minus 1 by 26. The reason is the slope of the tangent at x is equal to 5 is given by dy by dx at x is equal to 5. So here we can see that the reason is true, and we find the slope of the normal as minus 1 by dy by dx at x is equal to 5. So here the reason is true. Let us check whether the assertion is true or not. Slope of the normal, it is given by minus 1 by dy by dx at x is equal to 5. So first let us find dy by dx. Dy by dx, when we differentiate this, we get 8x minus 14. So dy by dx at x is equal to 5, it is 8 into 5, 40 minus 14, which is 26. So the slope of the normal, it is minus 1 by dy by dx at x is equal to 5, which is 26. So it is minus 1 by 26. The assertion is also true. So here both A and R are true, and R is the correct explanation of the assertion. So the correct option is option A. Moving on to the next question. The total expenditure in rupees required for providing the cheap edition of a book for poor and deserving students is given by C of x is equal to 3x square plus 36x, where x is the number of set of books. If the marginal expenditure is defined as dc by dx, the marginal expenditure required for 1200 sets is 7236. The reason is marginal cost is the derivative of the cost function at x is equal to 1200. So here we can see that the reason is true. Let us check whether the assertion is true or not. Here they have given the cost function is 3x square plus 36x, and they have given the marginal expenditure required for 1200 sets of books. It is 7236. So let us check this. So C of x they have given as 3x square plus 36. The marginal cost is dc by dx. It is 36x, 6x plus 36. Now dc by dx at x is equal to 1200. It is 6 into 1200 plus 36, which is 7200 plus 36. It is 7236. So the marginal expenditure required is rupees 7236. So the assertion is also true, and the reason is the correct explanation of the assertion. So the correct option is option A. Next question, the total cost function is given by C of x is equal to x square plus 30x plus 1500. The marginal cost units are produced is rupees 50. So we have to check the assertion. Reason marginal cost equal to C dash of x. So the marginal cost, it is the derivative of the cost function. The reason is true. Let us check whether the assertion is true or not. So marginal cost equal to the derivative of the cost function, it is 2x plus 30. So when x is equal to 10, marginal cost will be 2 into 10 plus 30. It is rupees 50. So the reason is also true. And here both A and R are true, and R is the correct explanation of the assertion. So the correct option is option A. Next we have questions from integrals. The assertion is integral e raised to x into x square plus 2x dx equal to e raised to x square plus c. Reason is the integral is solved using the rule integral e raised to x into f of x plus f dash of x dx equal to f of x into e raised to x plus c. So we are aware of this rule. So here the reason is true. Let us check whether the assertion is true or not. So let us take let I equal to e raised to x into x square plus 2x dx. Here f of x is equal to x square and f dash of x is equal to 2x. So from this reason, integral e raised to x into f of x plus f dash of x dx equal to f of x into e raised to x plus c. We have I is equal to e raised to x into x square plus c. So the reason is also true. Here both A and R are true, and R is the correct explanation of the assertion. So the correct option is option A. The next question, assertion is if f and g are defined as f of x is equal to f of a minus x and g of x plus g of a minus x equal to 4. Integral 0 to a f of x g of x dx is 2 times integral minus a to a f of x dx. Reason is if f and g are defined as f of x is equal to f of a minus x, g of x plus g of a minus x equal to 4, then integral 0 to a f of x g of x dx equal to 2 times integral 0 to a f of x dx. So here we have a different assertion and reason. So the reason is not the correct explanation of the assertion. Let us check which one is true among the assertion and reason. So let us take let I equal to integral 0 to a f of x g of x dx. So we can replace x by a minus x. using the properties of definite integral. So I is equal to integral 0 to a f of a minus x g of a minus x dx. But f of a minus x equal to f of x. So this is equal to integral 0 to a f of x g of a minus x dx. Let us add these two. Let us take this as 1, this as 2. So if we add these two, we get 2i equal to integral 0 to a f of x into g of x plus g of a minus x dx. But g of x plus g of a minus x is 4. So this is equal to 4 times integral 0 to a f of x dx. So we have 2i equal to 4 times integral 0 to a f of x dx. So I will be 2 times integral 0 to a f of x dx. So here we can see that the reason is true. The reason is true and assertion is false. So here A is false but R is true. So the correct option is option D. Moving on, the next question, assertion is if integral 0 to 1 3x square plus 2x plus k dx equal to 0, then value of k is 2. Reason, if integral 0 to 1 3x square plus 2x plus k dx equal to 0, then value of k is minus 2. So here we can see that the reason is not a correct explanation of the assertion. Now let us check whether the assertion is true or the reason is true. Integral 0 to 1 3x square plus 2x plus k dx equal to 0 implies, let us integrate this. Integral 3x square is 3x cube by 3. Integral 2x is 2x square by 2 plus k integral dx is kx with the limits 0 to 1. This is equal to 0. So when we substitute the upper limit, we get 1 plus 1 plus k minus lower limit is 0 equal to 0. So 2 plus k equal to 0 or k equal to minus 2. So here the value of k is minus 2. So the reason is true and the assertion is false. So here A is false but R is true. So the correct option is option D. Next question. Suppose that demand is given by the equation xt equal to 500 minus 50p, where xt is the quantity demanded and p is the price of the good. Supply is described by the equation xs is equal to 50 plus 25p, where xs is the quantity supplied. The equilibrium price is rupees 6. So here we have to check whether the equilibrium price is 6 or not. Reason, the equilibrium price is the price at which quantity demanded is equal to quantity supplied. So here the reason is true. Now let us check whether the assertion is true or not. So at equilibrium, the quantity demanded equal to quantity supplied. So we have 500 minus 50p equal to 50 plus 25p. Or we get 450 equal to 75p. From this we get p equal to 450 by 75, which is 6. So this is the equilibrium price. So here the assertion is also true. So both A and R are true and R is the correct explanation of the assertion. So the correct option is option A. Next question, the assertion is if the supply function for a commodity is P equal to 4 plus X and 12 units of goods are sold, then producer surplus is 72. Reason is when quantity supplied is X naught at a price P naught, producer surplus is given by P naught X naught minus integral 0 to X naught g of X dx, where this is the supply function. We are aware of this relation of producer surplus. So here the reason is true. We have to check whether the assertion is true or not. They have given the supply function as P equal to 4 plus X and 12 units of the commodity is sold. So when X naught equal to 12, P naught equal to 4 plus 12, which is 16. So the producer surplus, it is given by P naught X naught. 16 into 12 minus integral 0 to X naught, which is 12. Supply function, that is 4 plus X dx. So this is 192 minus 4x plus x square by 2 with the limits 0 to 12. So this is 192 minus 4 into 12 is 48 plus 12 square is 144 divided by 2 is 72 minus the lower limit is 0. So this is 192 minus 120, which is 72 units. So the assertion is also true. The producer surplus is 72. So here both A and R are true, and R is the correct explanation of the assertion. So the correct option is option A. Moving on. Next we have questions from differential equations. The general solution of the differential equation dy by dx equal to e raised to x plus y is e raised to minus y equal to minus e raised to x plus c. The given differential equation is solved by variable separable method. So here if we have to solve such a differential equation, we have to use variable separable method. So the reason is true. Let us check whether the assertion is true or not. Dy by dx equal to e raised to x plus y is e raised to x into e raised to y. Or from this we get dy by e raised to y equal to e raised to x into dx. Now let us integrate both sides. If we integrate both sides, this is integral e raised to minus y dy equal to integral e raised to dx is e raised to x plus some constant, say c1. So from this we get minus e raised to minus y equal to e raised to x plus c1, or e raised to minus y equal to minus e raised to x. Instead of minus c1, let us put plus c, where c1 equal to minus c, or where c equal to minus c1. So here this is the general solution, e raised to minus y equal to minus e raised to x plus c. So this is the general solution. So the assertion is also true. Here both A and R are true, and R is the correct explanation of the assertion. So the correct option is option A. The next question, the differential equation of the family of lines passing through the origin is x dy by dx minus y equal to 0. Now this we have to check. The reason, if the equation of the family of curves is given, then its differential equation is obtained by eliminating arbitrary constants occurring in equation with the help of equation of the curve and the equations obtained by differentiating the equation of the curve. So we obtain the differential equation by eliminating the arbitrary constants from the given equation and the equation which is obtained by differentiating the equation of the curves. So here the reason is true. Now the family of lines passing through the origin, it is given by y equal to m into x. So let us check the assertion. So this is the family of lines which is passing through the origin. So from this we have m equal to y by x. Now let us differentiate this with respect to x. Differentiating 1 with respect to x, we get dy by dx equal to m. But m we have obtained as y by x. So from this we get dy by dx equal to y by x. We are eliminating m from the given equation and the derivative of this. So we get x dy by dx equal to y, or x dy by dx minus y equal to 0. So this is the differential equation of the family of lines passing through the origin. So here we can see that both A and R are true, and R is the correct explanation of the assertion. So the correct option is option A. Next question. Assertion is if m and n are the order and degree respectively of the differential equation y equal to dy by dx the whole cube plus x cube into d square y by dx square the whole square minus xy equal to x, then the value of m plus n is 4. So this is the assertion. So for this differential equation they have taken m as the order and n as the degree, and they have said the value of m plus n is 4. This we have to check. The reason is both order and degree of the differential equation is 2. So here in this differential equation, the order is nothing but it is the highest order derivative which is there in the given differential equation. So in this the highest order derivative is the second order derivative which is d square y by dx square. So here the order is 2. The order is 2. The order they have taken as m. So m is 2. And next we have the degree of the differential equation is the highest degree to which the highest order derivative is raised. So here the second derivative it is raised to 2. So here the degree is 2. And here degree they have taken as n. n is 2. So the reason is true. The value of m plus n, it is equal to 2 plus 2 which is 4. And the assertion is also true. So here both A and R are true and R is the correct explanation of the assertion. So the correct option is option A. Next question. The solution of differential equation dy by dx equal to 1 minus xy plus y minus x is log of 1 plus y equal to x minus x square by 2 plus c. This is the assertion. This we have to check whether the solution is correct or not. The reason is the given differential equation is solved by variable separable method. So here we have to check whether we are able to separate the variables and solve. So let us do this. They have given dy by dx equal to 1 minus xy plus y minus x. Let us collect these two terms together. So it is 1 minus x and these two terms together plus y into 1 minus x. So this is 1 into 1 minus x plus y into 1 minus x, which is 1 plus y into 1 minus x. This is dy by dx. So we have dy by 1 plus y equal to 1 minus x into dx. Now this we can integrate both sides. When we integrate both sides, we get log of 1 plus y equal to x minus x square by 2 plus c. So this is the solution of this differential equation. So the solution of this differential equation is log of 1 plus y equal to x minus x square by 2 plus c. Assertion is true, and we have solved this using the variable separable method. This is also true. So here we can see that both A and R are true and R is the correct explanation of the assertion. So the correct option is option A. So this is how we go about in finding the answer for assertion reason questions. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. If you like this video, share it with your friends. Thank you for watching.